Hi. Hi, everyone. Can you hear me? Okay. Okay, great. So welcome to this webinar that we have. So we're going to start now. My name is Hadi Harb. I will go through this webinar with you. I am a lecturer at EIT. So let's get into it. What we'll try to do is we'll try to make the webinar around 40 to 50 minutes and then leave the last 10 minutes for questions and answers. So if you have questions, we can discuss them. Um, let's start first now. When you are on this Blackboard Collaborate interface, you can go down here to the settings, and on the settings, you can click on the notification settings. And if you want, uncheck all of this because otherwise you will be receiving a lot of notifications when someone logs in or logs out and when someone asks questions. So if you want to not have these notifications all the time, you might just uh, uncheck all of this. Okay, now today's topic is artificial intelligence and its use in industrial applications. And my name is Hadi Harb. I will be presenting this topic to you. I'm based in Barcelona, Spain, and I will go through this topic. Please remember that you will be receiving a copy of the slides and the video recording. So everyone who is registered with this webinar will receive the PDF slides and the link to the video recording within 2 business days via email. So please monitor your email. Also, there will be a certificate of attendance for this webinar. To access the certificate of attendance, please go to the link that we will be sharing at the end of this webinar. So you click on it, there's a survey, you respond to the survey, and you will get the certificate uh, within 4 days, 4 business days after you do it. Okay, so please remember regarding the certificate, I will leave the slide at the end of today's webinar on the QR code or a link. You click on it, fill in the form, and then you will receive the certificate within 4 days. What is, or a few words about EIT, Engineering Institute of Technology. It is an institute based in Australia, originally in Perth. It is an institute specialized in engineering, so we only provide engineering courses. The programs are industry oriented, meaning when the courses are designed, they're always designed with industry in mind. And when we develop the courses, we will often engage people from the industry to give us ideas and feedback about what is needed. It has all the required or important accreditation in Australia. So it's all the programs that you would have, they will be accredited in Australia. And you have also accreditations with Engineering Society, like in Australia, Engineers Australia. You have lecturers that are in general with a lot of, they have in general a lot of experience, industry experience. So the model in terms of lecturing at EIT, you would say it's not like the classical model of lecturers that are mainly academic. So here you have the academic background, but also experience, industry experience. So the aim is to have lecturers with both so that they can help the students at EIT by giving them also tips and tricks from the practice of engineering alongside the typical engineering teaching that are required. And the model here is a combination between uh, synchronized modeling and so synchronized, teaching or webinars like we are doing right now, and async meaning all of the webinars will be recorded, and then the student can watch the webinars later on, and they can submit their assignments. So it's a combination of um, synchronized and asynchronized teaching. And also there's online, so mainly it's online, but also you have campuses at EIT, you have campuses in Australia, so in Perth, in Melbourne, and in Brisbane. And so the student can select between on campus, online, or kind of a mixture. Okay, so I will be presenting this technical webinar to you. My name is Hadi Harb. As mentioned, I'm based in Barcelona, Spain. During the last 20 years of my career, which is basically my career. So I started work in 2000, so it's been like 24 years. I've been engaged in artificial intelligence and signal processing projects. I started originally uh, in 2000, so my studies were in engineering in the year 2000, and then I went in computer science, so initially in electrical engineering, and then computer science with a PhD and a master's from INSA Lyon in France and École Centrale de Lyon in France. Then I co-founded a company and managed it for roughly 14 years or so, 10 to 14 years, depending on like how would you define what the company does. And this company, so this was a startup company that developed and uh, sold technologies regarding recommendation, so music recommendation, video recommendation, and identification of signals. Recommendation similar to what you have on YouTube, for example, now when you click on a video and you have other videos that are recommended to you. So we worked on artificial intelligence, and we made a living out of artificial intelligence starting in 2005. Initially, we started with 2005, this company. And after that, around 2014, I restructured the company and made it more of a consultancy company after moving from France to Spain. And I started lecturing at EIT, which is what I do right now. So I teach units at EIT regarding artificial intelligence, programming, project management. And in the master's degree and in advanced diplomas, so we have what are called advanced diplomas at EIT and professional certificates. Okay, so I've been lucky actually to see artificial intelligence and work with it as an engineer, as a scientist, and as an entrepreneur, and also as a consultant and lecturer. And this is really, it was very satisfactory. Now, today what we'll be doing is look into this concept of artificial intelligence, the terminology that is used so that we are familiar with this terminology, and what is the requirement, or what are the requirements to build an artificial intelligence system, and finally some case studies. Some of them are inspired by projects that were done at EIT at the master's program, because at EIT we have master's programs where the students at during the last 6 months of their program they have to do a research project. So some of these projects, I will highlight them in a moment, were done actually during that research project, and they were applied in practice, like in real world scenario. These were real world problems that were solved. Okay, so let us start with an introduction of what is artificial intelligence. So artificial intelligence is making things like uh, basically you would call them agents, but these are software tools that we call intelligent, and they are not living. Okay, so we have our human intelligence is a carbon-based, we can call it a carbon-based intelligence because we are living beings and we have the intelligence. Machine intelligence or artificial intelligence is when this intelligence is created by us into certain agents that are software agents. But to reflect on intelligence, before we reflect on artificial intelligence, let's reflect a little bit about intelligence. So, what is intelligence? Is it, for example, having consciousness? We humans, we believe we are the only beings that have a consciousness. So, in this case, what about animals? Clearly, a lot of animals, when we look at their behavior, we consider that they are intelligent and they are not really conscious as at the level that we are. So, how in this case, what do you call them? Do you call them intelligent or not? Is intelligence about solving complex problems? One might think of a definition that intelligence means solving complex problems. But in this case, what is a complex problem? How do you define a complex problem? Is a complex problem, for example, making calculations? Because calculating, multiplying 235 by 1274.73 is a complex problem, right? For us humans. But it turns out it's quite simple actually to solve by a machine, by a calculator. So it's not really easy to say if intelligence is about solving complex problems, in particular, defining what is a complex problem. Is a complex problem recognizing objects? Like I take a picture of a car and recognize that this is a car and recognize the model of this car. Well, for us, it is very easy to do, we humans. But if you take a picture and you want to analyze it using a machine, it's much more complex. Is intelligence about making abstractions? Which is what we humans do. So it's another facet of intelligence, making abstractions. So we can say that intelligence is actually a kind of combination of all of these, like solving complex problems is intelligence, making abstractions is intelligence, having a consciousness is intelligence. Now, let's say that you develop a system that is intelligent. How do you gauge intelligence, the intelligence of that system? There's a test that you can do, and it's called the Turing test. And this test is to check if a system, so-called intelligent system, is able to trick a human into thinking that they are a human. Okay, it's like a chatbot. When you talk to a chatbot, the chatbot is trying to trick you into thinking that they are a human. And if you talk to Chat GPT, for example, most probably it will trick the majority of humans into thinking that they are a human. So this chatbot is succeeding in the so-called Turing test. Okay? So the chatbot is actually acting like a human. It doesn't mean that it is really intelligent as a human, even though it's impressive. When you look at ChatGPT, it's impressive, the type of answers it will give you. But in reality, the answers that they are given are kind of answers that were given at some level by some human. So it's just acting like a human. So chatbots fall in this category. You can also gauge intelligence by checking if a certain system or agent is acting rationally, is doing the right thing. Like, for example, optimizing. I would use a system that will optimize production. It will tell me that I should be operating at this particular temperature. If I operate at this particular temperature, we will get the best yield possible in our production. Okay? So in this case, this system, we can say it's optimizing, it's acting rationally. So it's a type of intelligent system. When we design controllers to ensure that our production is optimized, this is a type of intelligence that we are doing. So acting rationally. And then an intelligent system or agent could be built by making it think like a human. So mimic the way the human thinks. And this is where you have what's called the connectionist approaches. And this is the main type of techniques that's being used today. It's called neural networks or deep learning. So probably you have heard of this term deep learning or neural networks. In fact, the idea here is to be inspired by how the human brain works and implement it so that we make systems that are intelligent. And finally, you can make systems that are that think rationally. They apply logic and mathematics. Okay. For example, we can, and these exist. We can create a logic that says all humans are going to die. I am a human, so the system is going to deduce, hence I will die. So this kind of behavior or kind of thinking, we can implement it in computer systems. But clearly, not all intelligent behavior requires such logical deliberation. Now, other terms also important to clarify about artificial intelligence is what's called weak AI and strong AI. Strong AI or AGI, artificial general intelligence. Now, weak AI is when we are developing systems that we can call them intelligent systems according to any of these definitions that we saw before to solve specific problems. Okay? Strong AI or artificial general AI or general artificial intelligence is intelligence that is able to solve all problems humans can solve at least at the same level of humans. And some people are afraid of this strong AI or artificial general intelligence because it will be like super intelligence. Because if you build a system that's as smart or as intelligent as humans and it can solve all problems humans can solve at their level, just a next step, a small step, making these systems smarter than us would make them like um, go beyond us very, very far, very, very fast. Okay, but we are still far from artificial general intelligence. What we are doing today, what exists today, is what you would call weak AI. Okay, weak AI. We are able to solve specific problems, and we'll see some examples of these specific problems that are solved by artificial intelligence. Just a comparison between the human brain and the machine brain, if you want to call it a machine brain, which is like a CPU. The human has the computing in the neurons. So we have neurons, these are cells that look like this, and they are interconnected with each other, and they are mainly in our brain. So you have neurons basically everywhere, but everything will go finally to the brain where you have the main thinking. We have around 100 billion neurons. Storage, so data storage, is in the neurons themselves and in what we call synapses that are the interconnection between neurons. So two neurons will be connected by synapses. So we have around 10 to the power 14 synapses. This is storage. So all your memories are in these neurons and the connections you have between different neurons, the synapses. Computing cycle time is in the milliseconds. So you can think of computation is done at a milliseconds level, which is quite slow compared to what computers are able to do, so processors. In our processors, computer cycle times are in the nanoseconds, much faster. Storage, it's comparable. So we store the data, we have them in RAM, random access memory. So it's kind of comparable, 10 to the power 11 bits typically. And computing nodes are the transistors that you have on a CPU or on a processor. So we are, again, not far from the number of neurons in a human brain. So 10 to the power 9 typically on a normal processor. But still, you notice that humans can solve problems better than machines in general. If you look at the general type of problems solved by humans, it's way better than machines. Just the fact, just to recognize how good we are in solving, or our brains are in solving problems, just compare how a human can move, they control their body, because all of this is being controlled by the brain, sensing the environment and then moving around, jumping, moving, doing all types of activities. Compare how a human moves to the best possible robot and how it moves. You will notice that we will upload a robot and we are like excited when we see a robot doing some things that we humans do very naturally. And so like robots from Boston Dynamics, for example, or other similar robots. I invite you to check them. Just Google robots Boston Dynamics or Tesla robots. Okay, see how they move, and you would notice that we do at least as they can do, and even better, way better, with our brains, without really thinking hard about moving. Besides that, we think, we solve problems, we speak, we understand speech, we solve mathematical problems, we can recognize patterns. Okay, so our brain is very, very efficient if you compare, and if you compare the power being used, like it's probably 10 watts or so, really, really insignificant when you compare it to how much power machines need to consume to solve partially what we are able to solve. Okay? So this is a rapid overview of intelligence and human versus machines. Now let's get into practical things. What is the state of the art today? Well, we have autonomous vehicles, even if they are not really on the roads right now, but there are many areas, like industrial areas or areas where the problem is delimited, like in a warehouse where we have autonomous vehicles that are operating. They drive themselves. You have facial recognition, speech recognition. It's quite common now. Virtual assistants, again, quite common on smartphones. Forecasting at different levels is being used. Medical diagnosis. Diagnosis applied on machines, not only medical diagnosis, but diagnosis on machines. And artificial intelligence in these areas is doing probably better than a human. So if I take the example of medical diagnosis, there are artificial intelligence based systems that can do a better diagnosis than a medical doctor, including reading a medical image, for example. But it's not quite common because there are a lot of there will be a lot of resistance before this will be used. Okay, there will always be the need to have the human make the final decision, etc., etc. Same thing for autonomous vehicles. But for these problems and many other problems, AI solves the problem better than the human already. But we don't have artificial general intelligence in the sense that you have a single system that can solve all these problems better than the human. Now, terminology. We have the term that's called machine learning. So machine learning is a subset, it's part of artificial intelligence, and it is the ability of the machine to learn from data, to go beyond the initial program. For example, you might want to design a program to detect, say, a male from a female by listening to their voice. Well, you can analyze the signal, the sound signal, and recognize certain frequencies for males and certain frequencies for females, and then write specific rules. And you would say, if the main frequency is below a certain threshold, then this is a male. If it's above, then this is a female. Okay? Well, this is a method, this is an application that you can create. Now, the same system that you design, if someone asks you, can you adapt it to make it detect a gunshot and a broken glass, so the noise of a broken glass, well, you have to now analyze examples of gunshots, you as a human, and try to find patterns and find frequencies and energy levels and things like that. And you have to modify your whole program because you have to add new rules, write new rules. This is not machine learning. Machine learning will be about creating a program that will learn from data. So imagine now I create a program that you give it data and you tell it, here is what we would call a male, here is the sound that we will call a female, and you have to train. They will learn, and now next time you give them a sound sample, they will tell you if it's a male or female. And now if you want to change, you want to make the same system recognize a gunshot. Simple. You give it examples of gunshot and you tell it, here's a gunshot, here's a gunshot, give it multiple examples. Next time it will hear a gunshot, it will tell you this is a gunshot. This is machine learning. So it will go beyond the initial program. It's like what you would do when you are um, teaching a child. Teach a child to distinguish between things. So you give them examples and you tell them, this is a car, this is a bus. Give them multiple examples, and after that, they will learn to distinguish car from bus. Now, next day, you want them to recognize what is a ball or what is a basket. You give them examples, and they will learn. This is the beauty of our brain. It is able to learn. So it's not coming with a program that already exists that stores everything that we should do in life. No, it has this ability to learn. So machine learning is to try to do something similar. Now, in machine learning, we have what's called supervised learning, we have unsupervised learning, and reinforcement learning. So let's take a look at these. So supervised learning is when we would tell the machine to distinguish between things, and we will be telling it, this is A and this is B. I want you in the future to recognize A and B. As I mentioned, it's like when you are teaching a child. You give the child an image of a car and you tell them this is a car. You show them a picture of a bus and you tell them this is a bus. And later on, when you show them a picture, they can tell you if this is a bus or a car. This is supervised learning. So the teacher will be supervising the learning process. And in machine learning, we do the same. So here in supervised learning, it could be done for classification. Classification, for example, here on the left, I have a sound signal. So if you give me this sound, or you give this sound signal to a machine and you tell it, this is a male, let me call it M. Another sound signal, you tell it, this is a female. After giving it sufficient data, it will learn to distinguish between a male and a female. So sound classification. Here, this is handwritten recognition. So I write something by hand, I produce images, so you take a picture of these, train a system to tell that this is a 6 and this is an 8. And by giving it sufficient data, it will recognize now. So if you write something down by hand, you give it the image, it will tell you what you have written. This is now handwritten recognition. Here, we have image recognition, eventually face recognition. Okay, so you give it different examples of pictures, and you tell, here we have a face. Here we have multiple faces. In other images, we don't have a face. So now the machine will recognize when we have a face, meaning when we have humans in the image, when we don't. And these kinds of systems exist in our smartphones that will analyze the different images we have and will present the images for you, like most interesting ones that are typically when you have humans in them. So this is image classification. Here we can do text classification. Like we have a text, who is the founder of Apple? And Apple, like we have a text, who is the founder of Apple? And Apple, it will be recognized as the organization, Apple. Okay? Not the, uh, like not Apple, the fruit, the organization Apple. Now it's a text classification. Okay? So we call this classification, and the type of learning is supervised learning because we will be providing the data to the user, or sorry, to the machine learning system. We will provide it the input, like the image or the sound signal, and we should provide it with the output. What you want this system to say as an output, what kind of class. You have also what's called regression. Regression is when the output is not a class. You want your system to predict something that is a number, a value. So it's not a class. For example, if I want to predict electricity demand, in a certain city or neighborhood. Well, this is a problem where I would call it a regression. So the way we'll do it, we can apply supervised learning, provide sufficient data where we have the input here. So the input is day, hour, month, temperature. The output is electricity consumption. And another day, etc. So you have these data with the inputs, some variables that are important and we believe they could be suitable to make predictions, and the electricity production. We give them to a machine learning system. The machine learning system will learn. And now if I give it this input, it will give me the predicted electricity demand. Okay? So in supervised learning, whether it's classification or regression, what you need already data, like historical data, where you know what is the input. The input is whatever you are going to give to the machine, and you know what should be the output, meaning you know what the machine should tell you. You prepare this data, and then you train the machine on this data. Once we finish the training, we give the inputs to the machine or to the algorithm or agent, it will give us the output. So you use regression in things like forecasting, pricing models, performance, weather predictions. All of this is regression. And we have a lot of applications that exist today. Now, when this regression is about predicting a value that is a function of time, we call this time series analysis. Okay, so we call this time series analysis, meaning the variable is a function of time. Okay, so here typically it could be production or sales or something like this. You want to predict the production or the sales tomorrow or next week. Now, what do you do to make such predictions? You would use the past, so historical data, to make predictions of the future, and eventually you would use some other things, like is it a what's the temperature outside? Probably demand on if I sell ice cream, the weather could be a predictor of how much ice cream I'm going to sell. Okay, so we can use such information to predict the sales or production or stocks, which is quite difficult actually to predict. Now, unsupervised learning is another type of learning where we do not make the predictions. We don't have like an input output that we want to start with. We do not supervise the training process, the learning process. We do not supervise it. What we'll do is we'll just give data to the machine and allow the machine to cluster the data or find patterns in the data on its own. Okay? For example, I can give the machine certain data like I'm measuring here the height and mass of a human. Okay? So we have different humans, human 1, human 2, human 3, and human 4. And let's say that we plot them here. Here we have height and here we have mass. So human 1, human 2, human 3, human 4, something like this. Okay? The machine would say, I have a cluster here and I have a cluster here. It creates these clusters. It will do the segmentation on its own. And we have algorithms that will allow us to do so automatically. So you just provide the data. There's no output here. There's nothing, for example, that will tell probably that a human 1 and a human 3 are males and human 2 and human 4s are female. We are not given this information. The machine on its own is going to find patterns in the data. So where do you find patterns in the data? Where do you apply this so-called clustering? You can apply it in customer segmentation. Very important to do such clustering, customer segmentation, because it will allow you to group customers by group. So instead of communicating to all your customers in the same way, you would split them. Here you have this type of customers, other type of customers, other type of customers. Probably each group of them or each group that you have, you need to communicate with them in a different way. Okay, if I am a farmer, you have to communicate with me in a way different than if I am, I don't know, a lawyer, for example. Okay, my interests will be different. So if you want to sell me your product, you would have to communicate differently with me. So this is a very important application of machine learning, which is here unsupervised learning, meaning clustering in particular, and used in practice for optimize marketing and communication. And there are many other applications, but this one here is like stands out. We can use also the artificial intelligence techniques to represent knowledge. So knowledge, for example, you have experts in a certain domain, in a certain field, like medical doctors or engineers or so, and they have a certain knowledge. You want this knowledge to be mapped into some artificial intelligence agent. Well, we have techniques that will allow us to do so. For example, we have what's called a decision tree. A decision tree will allow us to decide based on questions. Like you ask the first question, does the patient have this symptom, symptom one? If you say no, they will ask you, does the patient have symptom two? If yes, you would say, here's their illness. Okay? So decision trees are the way medical doctors would do diagnostics, engineers would do diagnostics. We rely heavily on decision trees. But we create those decision trees usually by hand. So we ask questions and based on experience. So with experience, we start asking these questions to decide. Just think about when someone goes to a medical doctor and they start asking them, what do you feel? What kind of symptoms did you have? Now, depending on the response, the next question will be different until they will give you a diagnostic. Same thing if you are a mechanic and you are asking the client about what they saw in their car and you want to detect what was the problem. So you start asking questions, and depending on what the client will respond or what you will test, you will go and try something else or ask something different. A decision tree actually could be built automatically using machine learning. So we just have to provide examples to the system of how experts decided. So we can give examples of patients, for example, with all their symptoms. We write down all their symptoms, and we will tell the machine learning system what was the diagnostic of the medical doctor. Okay? When you give sufficient examples, you can run an algorithm, and this algorithm will generate a decision tree. Now, next time you want to apply, the decision tree is already there. So very, very useful to encode like the human wisdom into things like a decision tree, or what we call ontologies. Ontologies meaning relationships about describing the world. Okay, like if A is the child of B, then B is the parent of A, and apply such rules similar to what we've mentioned before when I said logic, like all humans are mortal. If I am a human, then I am mortal. So we can encode such information using ontologies. Question answering, like chatbots, are a great way actually to represent knowledge. And companies are starting to integrate this. It's not really very successful because you see on a lot of websites you see chatbots, right? Now those chatbots, in theory, they should be encoding the human wisdom, like customer service wisdom, and they should be useful to you when you talk to them. But the grand majority of websites, they are kind of useless, these chatbots. Okay, just compare them to ChatGPT. And now, if you are not familiar with ChatGPT, just Google it, ChatGPT. Okay, so in general, one would expect every company to have its own ChatGPT, encoding all its wisdom, the wisdom of its employees, and deploying it. So using it in different areas, different applications, like as an interface to customers or internally within the organization. But so the technology is there. We can build this. Reinforcement learning is the last type of learning where you create an agent. The agent will observe the world, so it has sensors to observe the world, and it can perform actions. So it can act. It's going to act, see what happens, and it wants to optimize a certain function. Basically, it's like it wants to optimize its rewards or maximize its rewards and minimize its punishment. It's very similar to how humans actually learn and animals learn. So an animal, if they do the right thing, you give them food. If they don't do the right thing, you don't allow them to get food. Okay? So by doing so, the animal will learn later on to do the right thing, like to do what you asked it to do. Same thing with the humans. So if I touch something and it feels hot, I get burned. Next time I see something similar, I wouldn't touch it. So this is reinforcement learning. And there are algorithms that are used for this reinforcement learning. So here you just leave the agent to interact with the world around it and uh, would try to learn to maximize its rewards and minimize the punishments. So to build now an AI system, what do we need? If you are building a supervised learning system, you need to gather data. The data that you would gather, you would have to pre-process it and label it. When I say labeling, it's really the important part, meaning if it's supervised learning, you need to tell the machine for a given input what should be the output. So you have to write down what should be the output. This is probably the most demanding step. After collecting the data, cleaning it or removing what's not like relevant, you have to label it, provide the output. And then you can do what's called a feature selection because not all data or not all variables that you are measuring will be important. Train a model, evaluate it, and then you deploy. If you have data where given certain inputs, you know what should be the output, you can in general build a machine learning system that will do this later on automatically. If it's unsupervised learning, you would be gathering data. Now there will be no labeling because you don't have to label. It's unsupervised. You would have to define things like a similarity function because the clustering or the segmentation is based on a similarity between data points. So you have to define some similarity function. If you are representing humans, how do you compare to humans to say they are similar or not? Customers, how do you compare to customers if they are similar or not? So you need to define some kind of profile and define a similarity measure. Once you have the similarity measure, you can build a model and it will create those clusters automatically. So you can deploy that system. And reinforcement learning, we need to define what is a state. How do you represent the state of the world using the sensors? How do we define performance? We should define the performance. And the reward, how do we give reward to that agent? So when they do a good thing or a bad thing, and then you would evaluate your strategy and deploy that system. Some techniques that are used in AI, artificial neural networks, k-nearest neighbors, and all of these here. Artificial neural networks are what we would call connectionist approaches. This is the example that I mentioned, like think like a human. And they are a model of a neuron. So they could constitute a model of a neuron that we have in our human brains mainly. And these neurons are connected together. So they are connected via synapses. So, but it's all modeled. And you have inputs that will be introduced, sensor inputs, and there are outputs that will be produced. The outputs could be used for classification or a probability. Okay? So the model of a neuron is actually simple. The output will be the weighted sum of the inputs where we apply some function on it. It's really simple. And it is the basis of what we are doing in artificial intelligence today. K-nearest neighbors. Now, k-nearest neighbors here, it's a classification technique where we classify an object based on the class of its neighbors. So if the neighbors are class failure in a machine, then we say it's a failure in a machine. Okay? So these are just examples of two techniques, very, very common. What kind of tools do you use if you are applying machine learning today? You can use Python with scikit-learn or TensorFlow. You can use Python with scikit-learn or TensorFlow. You can use Weka. It's a great tool. We'll mention it in a moment. You can use MATLAB, and you can build machine learning systems on the cloud. IBM Watson, Google Machine Learning, Microsoft Azure, etc. The objective here in this webinar is not clearly to do programming, but just to show you an example of how you can build a machine learning system that will recognize images. It's not really very complicated, using TensorFlow. Here it is. This is the first part of the code. I'm not getting into the details of it, okay, but just to show you how short the code is. So this is the first part of the code. The data would look like this, where we would want the machine learning system to recognize that this image is actually a dress. And here we have the actual code. Okay, so that's it. This is a program, this like what, 10 or 20 lines of code. This is a program that will recognize, that will let you build a machine learning system to recognize the image, what type of image we have. Here's another tool, great tool. This one I invite really to download and try from this URL here. It's called Weka. This tool will allow you to open files, typically CSV files, that have already your data in supervised learning or unsupervised learning, and you click on a button, and it will create a machine learning system for you. Okay? Now, MATLAB is also a great tool that you can use for machine learning. MATLAB is used by engineers and scientists. They have a toolbox, great toolbox that you can use to create a machine learning system, train it. For example, here, this is a neural network, and build your system. In fact, it's not really very complicated. If you have the data, in 2 minutes, you can create a machine learning system and apply it. It's all about the data, having the data. So in summary, if you want to program and you have experience in programming, you can create things using Python or using C++. And if you need flexibility from scratch, or again, using Python or MATLAB, and then you have other tools. You have R. It's a tool. You can Google it. R project, download it. A great tool. Weka, if you want graphical user interfaces. Okay. Now let's take a look at some case studies where machine learning is applied. Now some of these cases, now Python and R, both of them here are mentioned. But in reality, these are the frameworks or the programming languages that we'll use, but they are quite used for machine learning and AI. Now, here are some applications in predictive maintenance, control, fault detection, recommendations, and chatting. This is a case that was done, as I mentioned at the beginning, at EIT in a master's program, a master's thesis. So the idea is there are motors here. So these engines, so the aero engines, there's a type of failure in these engines that's difficult to detect unless you open up the engine. So the idea was to capture sensor data from these and apply a machine learning on the data to try to predict when there's a fault. Okay. So the types of data were things like this here, like speed, pressure, temperature, exhaust pressure, etc. And it was applied using this architecture is actually a neural network to produce the class that is there a fault or not fault? Okay. And it worked very, very well. So here you can see in yellow, this is the condition when there's a fault, and the machine learning system was able to detect the condition in all cases. Okay. So this is an example, or it's an application of applying machine learning to something very, very practical, is to detect a type of fault in an engine by analyzing the data that people already have from the sensors. The data is already there. So gather the data from the sensors. This is supervised learning here. Supervised learning where the author here had to go through the data and distinguish when there was a failure in the past by asking maintenance people when there was a fault and trained the system. After that, the system was able to do the classification on its own, and it worked just fine. Here, this is another example of a thesis that was done also at EIT, where the author wanted to make predictions of water level in a boiler. So we have a boiler that produces steam from water, right? It boils water. The drum level, which is the level of water in this boiler, is an important variable to keep under control. Now, to improve the control of the drum level, one can improve the control by making predictions. What will be the level at the next 1 minute or 2 minutes or 3 minutes? It will be very useful because otherwise, if the control is not done correctly, the boiler will shut down. If it shuts down, it could be very costly. So this was another example where machine learning was used by analyzing the data that was already available in the control system to make predictions of what would be the drum level, the water level in the drum in the next few minutes. Here's another example, also another project that was done at EIT, where the idea was to detect the electric motor bearing faults by capturing signals like vibration signal from the electric motor. So if you have electric motors, and there are certain faults on the electric motors, in particular the bearing faults, by listening or by capturing the vibration signal and applying, so here the vibration signal will look like this, applying a neural network, the faults were detected. And in this case, it was 100% of the case of the time. So 100% accuracy. Another example where machine learning could be applied very effectively on data that already exists. Here, predictions, electricity demand forecasting. You can predict, for example, this here for electricity demand forecasting in Spain. Okay, so we can train the system to learn from the past to predict the future. It's not perfect, but it gives us an indication of what will be the electricity demand in the next few days, for example, here in Spain. Solar radiation prediction. We can use such system to predict what will be solar radiation given information like this, like time, what's the time of the day, what's temperature, what's pressure, what's humidity, etc. Based on this, we'd want to predict solar radiation. And we can imagine this being used in a context of solar electricity production. So these are some examples where it is practical. So you can apply machine learning. Basically, it's data analysis, but people would call it more machine learning or deep learning because it's more exciting to use these terms. But it's basically data analysis. You are analyzing data to make predictions or to make classifications. Now, here's the last example, which is a chatbot using, again, neural networks. This is a chatbot that I personally trained. So how I trained this chatbot? I trained it on movies. Millions of turns of conversations from movies. So I trained the chatbot to produce what one actor says in response what the previous actor says. So you can have access to these. You have millions of turns in a conversation. I just trained the neural network to produce the response from the previous sentence, okay? And then I conversed with it. So the question is what I would ask that chatbot, and the response is this. So you say, hi, it says, hi there. Where were you last night? I was in the bathroom. What's your name? My name. Yes, your name, please. My name is John. How are you today? Fine, I'm doing great. Do you like to go out with me? Sure. I like you. I like you. I love you. You know that. I love you. Let's go grab a beer. Come on. I gotta go now. And it will say bye. Now, this here is a system that is trying to act like a human. But in reality, it is just trained to replicate basically what humans or what actors said in response to what other actors said in movies, in millions of conversations. Okay, so this is an example of a chatbot. And in summary, if you have data in your organization, in the problems that you are trying to in whatever business that you do, if you have data, if you want to make predictions, or you need to make some optimization of your operations or your control, you can use AI. You can use machine learning. Okay? So you can use machine learning to make predictions, but the key point is that you need data. The examples I mentioned today were examples where the data existed. It was already on the control systems, it existed. Okay, so it's the idea is just to prepare the data so that machine learning can be applied, or in general, AI can be applied. Okay, just a few words here about what courses at EIT cover this topic, because clearly in 1 hour, we cannot cover everything AI and machine learning. Okay, it was a high-level introduction. Now, courses here, we have this professional certificate of competency, advanced diploma of robotics and mechatronics, bachelor of science, and master of engineering. All of these, they cover units in AI. And these are upcoming courses similar to or other courses that we have at EIT. So all of these here certificates or graduate certificates. These are upcoming webinars. So please check them when you receive the PDF. And finally, this is the link you have to access to get the certificate of attendance. Okay, so please click on this link or scan this code, fill in the form, and then you will get the certificate. Okay, I'm going to leave the slides here on this one so that you can access it directly. Okay, let me check. So we have like 5 minutes. We can spend 5 to 10 minutes on questions and answers. Okay, so let me check if I can see some questions. Okay, so difference between AI and machine learning. Exactly, as I saw, there was an answer. Exactly. So machine learning is actually a subset of AI. Okay. If you have questions, please let me know. So let's try to answer some questions in 5 minutes or so. Okay. How much the deployment of model and sensors with detected defect in machines? In fact, it wasn't much. Like $200 or $300 will be sufficient to have all the sensors that are needed. Sensors do not cost much. Okay. Okay. Research ideas for industrial AI. I invite you to go to here, like scholar.google.com, scholar.google.com, and then you can check there. You will see there a lot of examples. You just Google AI industrial, and you will see a lot of examples there. Okay. Okay. Kibazo, please send me an email if so. My email is my name, so I think it should be available. So Hadi dot Harb at eit.edu at eit.edu.au. Okay. Any chance AI would take over automation and process industry? I would say it's already taken over. And in automation industry, it's like just a next step. So it's having a feedback controller is already a machine intelligence, but it's going a next step. How does mechatronics and AI relate? Now, mechatronics is whenever you have system, basically in mechatronics, or at least in the advanced diploma that we have at EIT, we deal a lot with robots. Okay, and one of the things in robots is you want the robot to be able to navigate on its own, like autonomous navigation. You want it to make decisions. So this is where you would use AI with robots in this case. Okay, so make predictions, navigate, motion planning. What you recommend to start machine learning? I would say you need to identify a problem where you would want to make predictions. If you go to Weka, the example that I mentioned, or the software that I mentioned, um, if you read a little bit about it, you will see that there are already data sets within Weka that you can see, they can inspire you. Like, for example, one of the data sets will allow you to detect the type of cancer, breast cancer. So breast cancer, whether it's malignant or benign, or breast um, lesions that are malignant or benign. Okay, so this is an example. So it's basically by seeing examples, but ideally you have something that you want to predict. Okay, are we are to create our own AI or use AI in our works? Now, basically, we will be, I would say, training AI. So this is like what the majority of people will be doing. We'll be training AI. So the AI algorithms will exist, the systems will exist, we'll be training it, guiding it, giving it data and get responses from it. Because building an AI system is really not very complicated. What we need the data to guide it. Okay, can machine learning be done in any programming language like C? Yes, absolutely, but it will take you a lot of time. Okay, so ideally you would use something that already exists and you concentrate on training the machine learning system or AI application instead of building it from scratch, because it is really module on top of a module on top of a module on top of a module. Okay, you can do it from scratch, but it will take you a lot of time. Okay. Can we have a list of sensors? Are these sensors set to come with Raspberry Pi? In fact, here for the engine itself, the sensors were, or if you, for the electric motor, these are normal sensors that you can find on, I think it's a website called DF Robot. And the sensors that you will get are vibration sensors that are, if not a Raspberry Pi, they are for Arduino. They will be great for Arduino, okay? Because you have already the data acquisition system. Vibration sensor to detect faults in electric motors, in general, yes, it's sufficient. Gailani, is Tesla robot considered a strong AI? No, no, it's still what you would call a weak AI. The email, sending the presentation, as I mentioned, here's the link. Please fill in the link and you will be receiving actually this by email. Everyone who registered will receive the presentation PDF by email. Okay, unfortunately, I cannot copy here the link. So it's a PDF on the screen. I cannot copy it. So please type it on your URL. I cannot copy it to paste it here, unfortunately. How AI can be used in manufacturing, input their ideas into a chatbot initiated manufacturing process. I'm not sure here because it will depend on the case. So in manufacturing, I would say AI can be used in terms of forecasting, or at least this is what's used today, forecasting, when you have a forecast of what will be the demand in the next few weeks or months, and you can use this as an input to the manufacturing process. So in terms of operations, it will be an input to operations. Predictive maintenance, it basically works with symptomatic signals. Basically, it will the machine system that you or the machine learning system or the AI system that you will be developing will receive signals from sensors. Now, if you can apply it also on a human, like I can receive signals from sensors on a human, like heart rate, temperature, whatever accelerometer a human is wearing, and from there make predictions if they have a certain illness. So always in predictive maintenance or in diagnostics, you would want to receive signal data and you would want to predict if there's something wrong. But in general, it is supervised learning, but there are methods that you can apply where it's not supervised learning, so unsupervised learning. Okay, can AI be used for ERP, parts, consumption, prediction, and thus stocking? Absolutely, absolutely, yes, yes. Whenever there's something to predict, forecast, AI is clearly can be used. AI used for robotic arms executing tasks. Now, in general, robotic arms executing tasks are following a fixed program. There are reasons also for this in terms of safety, because a robotic arm, if it does like what it wants, it can crush someone. Uh, Personally, from what I see, it's more a robotic arm has a fixed program that will execute. It's not going to do the execution like based on some algorithm where it's like a black box. Okay, weak AI is already an application. Please share cases. In fact, weak AI is an application everywhere around us, even though we are not like seeing it or explicitly seeing it. There are many companies that are relying on making predictions, okay, of how much they would have to sell. This is weak AI being applied. Can I build a deep learning model with Python? You can build deep learning model with Python, absolutely. Now, manage operations ORAN architecture. I'm not familiar with ORAN. Yes, please go ahead on LinkedIn. Please connect on LinkedIn. Can AI be integrated with DCS in process chemical industries? It will be on a case by case, but usually the developers of DCS systems are including more and more AI or machine learning modules there. Otherwise, you would have to create some interface between the DCS and the machine learning system. What parameters would be good for sales prediction model? Typical parameters for sales prediction would be the day, would be if is it a weekend or not, the weather, and other things like previous sales. Usually with these, you can get a reasonable job in predicting. How to balance AI versus NI? I would say AI is developed. At some level, we would have to collaborate heavily with AI, with humans. Which industrial profession is AI more likely to be applied in the future? It seems that everywhere you can apply AI. Even in industries where people thought they are protected from like automation, AI, for example, teaching, AI will affect teaching significantly. Areas where you have more of a human interaction, to some extent, creativity, are going to be less affected probably by AI in the near future. But mainly it's a human interaction. Thermal cam with AI absolutely can be used, thermal cameras, but it will be the thermal camera in this case will be a sensor like any other sensor. Okay. Okay. I'm sorry, everyone. I cannot really go through all the questions. I would have to close the session now. I'm sorry for that. Um, what will be I'll keep this slide here so that you can log in to this URL and then use it to access the form and then receive the certificate. Okay. So thank you everyone, and my apologies because we cannot really extend the webinar any further for more questions. Thank you everyone. Thanks. Bye bye.